Whenever I see an equation with fractions, such as this, my first impulse, and usually the first thing that I try to do, is to get rid of those fractions. So how could we do that? What would we do to this equation that would eliminate the fractions? Well, if we just focus on this side, let's think about it. If we just focus on this, what could I multiply by that would get that p out of the denominator? Well, I could just multiply it by p, right? That way those p's are going to end up canceling. That's how it always works with fractions, right? If I just make a little side note here, if I have, I don't know, just some fraction, say 2/3, and then if I multiply this by the denominator, if I multiply this by 3, well, those 3's just cancel, and I'm left with a 2. The same thing will happen up here, and my denominator will be gone. I'll be left with an r. But if I'm multiplying this whole side by p, of course I have to also multiply this whole side by p. And if I'm multiplying the whole side by p, that means I have to multiply each of the terms by p. So this term, this first p, I'm going to multiply that by p. And I also have to multiply this second term, this more complicated term, by p. So let's see what happens if we multiply this out. My first term, p times p, is just p squared. And my second term, well, it's going to be just like this. I have p times a fraction with a p on the bottom. So just as these 3's canceled out, my p's are going to cancel out. So what's left is just of the term is the numerator, and I'm going to keep my parentheses there, right? Just to remind myself that I'm subtracting what's left of this whole term. So what's left is 1 minus p squared, and I'm subtracting that whole thing. I think probably that is the step in which most points are lost on this question, forgetting that when those p's cancel, we're still subtracting the whole numerator there. And those parentheses are a good way to, that's what I like to include, to remind myself that I'm subtracting that whole numerator. All right, and then this side we already know what happens. The p's cancel, and I'm left with an r. So we've actually already done it just by getting rid of the fractions. We have isolated the variable we're looking for. We have an r on this side and a term with p on this side. Although it doesn't match our answer choices yet, so let's simplify this a little bit. Still got my p squared, and got to figure out what to do with these parentheses. And I've got minus something in parentheses. That means I have to distribute my negative to each of the terms in there. So I've got minus the first term, distributing to the 1, I just have minus 1. And then distributing to my minus p squared, I have minus p squared. This whole thing equals r. And what does this become? We've got p squared minus 1 minus p squared is the same as plus p squared equals r. And I can combine like terms. I've got a p squared plus a p squared, which is 2p squared. And I've still got my minus 1. And this all equals r. And this finally does match an answer choice. It matches answer choice D.